Hey everyone, in today's video we're going to be talking about the angle bisector theorem and how it works with triangles. Let's go ahead and let's get started. So here we have the angle bisector theorem. Alright, the angle bisector theorem, just like any other theorem geometry, says if you meet certain conditions then you can assume certain things. So here we have our first example of what conditions we're looking to meet. We have two triangles that are sort of back to back, and we see that we have two perpendicular angles. We have two 90-degree angles. And what the angle bisector theorem states, and it's called the angle bisector theorem because it involves one angle that was cut in half. We're talking about this angle right here. Angle B was cut in half by this ray BP, which is why it's called the angle bisector theorem. So it leaves us with two congruent angles that are attached to B. Whenever we see this, two angles like this that are in this spot, two 90-degree angles as well, if this happens, then we are allowed to assume that these two sides of the triangle, AP and CP, are actually congruent to each other. Alright? So that's what this theorem states, and the opposite is also true. If we start off and we see the triangle, and we know that we see two 90-degree angles, and we see that AP and CP are actually equal to each other, then we can assume that the angles near angle B are both congruent to each other. Okay? Remember, converse is just take the theorem and flip its order. Okay? So now we're going to look at what does it look like when we use one of these theorems in a problem. How can it benefit us? So let's go ahead and look at a geometry problem that involves this theorem. So here we have it. It says we have this diagram, and it says if the measurement of angle YXW is equal to 21 degrees, YW is equal to 5, and WZ is equal to 5, what is the measurement of angle ZXY? So let's go ahead and label these. Angle YXW. YXW. So they're talking about this angle on the inside. They're saying that angle is 21 degrees. Awesome. YW is 5. So from Y to W we know is 5. And then they go ahead and say WZ is also 5. From W to Z is also 5. What is this whole angle? Okay, so in order to find out what that whole angle is, I'm missing this smaller angle by X. But I can see here that I have two perpendicular angles, which to me is a red flag to it's probably going to use the angle bisector theorem, or the converse of it. I also see that these two sides are equal to each other. And I know by the converse of the angle bisector theorem, this is exactly what I have. I know that those two angles on the inside have to be equal to each other. So, these two have to be equal to each other, which means if I know the one on the outside, I know the one below it is 21 degrees as well. Now to know what the full angle of ZXY, I simply just have to add these two. 21 plus 21, that would be 42 degrees. So this was an example of how we could use the converse to help solve this. Now let's go ahead and let's look at another problem. Here for this problem, it reads, if the measurement of angle YXZ is 38, and the measurement of WXZ is 19, and WZ is 8.1, what is the value of YW? Again, let's label this. And again, off the bat, just by seeing these two 90-degree angles here, I can already tell I'm probably going to use one of the angle bisector theorems. But if YXZ, so they're talking about this big angle, YXZ. They're saying that that angle is 38 degrees, that WXZ z, so from w to x to z, so that angle is 19 degrees, and wz is 8.1, so from w to z is 8.1. They want to know what is y to w. So from y to w, this part right here, they want to know what's the length of that. So if I want to use the angle bisector theorem, I either have to have these two backsides equal to each other, or these two angles equal to each other. There's no way to me to prove that those two backsides are equal to each other. So I have to see, can I prove that these two angles are equal to each other? And there has to be a way for me to find this angle if I want to do that, which there is. If the whole distance is 38 and this lower angle is 19, I can subtract those two. I can do 38 minus 19, and it should give me that orange angle, which in fact ends up becoming 19 degrees. Which means that these two angles are congruent, which by the angle bisector theorem for triangles, I know that that means that this also has to be 8.1, which answers the question, YW has to be 8.1. So hopefully now you feel like you can use the angle bisector theorem and that you understand it and you can apply it to certain problems. Definitely check out some of these other theorems that will come out soon about triangles and how we can use bisectors as well. Okay, we're still going to use angle bisectors and we're going to use perpendicular bisectors, so stay tuned for that. And as always, just want to thank you for watching, and I hope you learned something today.